Hey students, we're going to start some nomenclature today, which is a big fancy word for naming, and it really is not as hard as that big long word makes it sound like. But I want to let you know before we get started, we're going to be covering some notes that look like this, and you can find them in Canvas. So you might want to download them so you can look at the blanks that are being filled in as we go. And especially important, you're going to want a polyatomic ion list. Now, of course, I have one in Canvas, but you can just go to the internet and download a list of polyatomic ions. They're all over the place. You would want that as a reference because you're going to need, we're going to talk at the end about polyatomic ions. You're going to want that list. I'm not requiring you to memorize any polyatomic ions. I want you just to look at the list and be able to find them. Okay, so you want to be sure you have that before we get started. All right, so we're gonna talk, we recently have done puzzle pieces to show ionic bonding. And after gluing the puzzle pieces together on the paper, I had you put the formula and I had you put the name. And that's what we're actually talking about today. How do we do those formulas and names, but without puzzle pieces? So let's just start with the puzzle piece. So I have this puzzle piece here. And as you can see, I have one calcium piece, it's real big, and two smaller iodine pieces going on here. And I hope you recall from building the puzzle how you made the formula. Did we not say it was CaI2? One calcium piece, and we don't write ones, okay? There's like a little subscript one there. We don't normally write ones. And then I2 because there's two iodine pieces, right? Okay. So that's how we get the formula when we see a puzzle piece. Now, to show you how we do this without seeing a puzzle piece, I want you to see a really neat thing that happens. Notice, I want you to look here. I want you to see what this number is that the arrow is pointing under versus this number here. And when we don't write a number, there's a 1 there. And what number is here after the CA? So do you notice what happened? The numbers swap. In fact, this is super great because this tells us how to get a neutral compound without like any math going on. It works 100% of the time. It is so great in chemistry that finally I got something I can tell you guaranteed works all the time when we want a neutral compound. We can crisscross the charges. And that's what we call this. We call this the crisscross method. So like even, college professors, professional chemists out there, if you need to make a compound, they're going to do the crisscross method because it works all the time, which is really nice. All right. So I want you to give this a try before we move on. So what would the formula be if I have NaNO? Give it a try, pause the video maybe a moment if you need a moment to write down. And then you can unpause when you've got an answer. I don't want you like cheating and looking the answer before you write it down. Okay, so the 2 from the oxygen goes to be with the sodium, and the 1, and just because I want to save time, I'm not going to write a 1. It goes like that. Now, would I count you wrong for not putting, if you did put a 1 there? No, I wouldn't count that wrong. But we're going to have 1 so many times this year. I want you to not put 1s to save yourself a little time. That's for your sake, okay? All right, and then try the next one, and again, pause. Write it down. Don't try to skip ahead. It should be, like it doesn't get easier than this. Okay. And there we go. So the 3 goes with the CA and the 2 goes with the N. Now, I want to point out as we do this, we are not bringing down any of the charges. I am not showing a positive or negative. It's just the numbers, because what we're doing is we're showing how many atoms of each are needed to zero out, to neutral the compound. Okay, so check this out. What is 3 times positive 2? Positive 6. What is 2 times negative 3? Negative 6. I have positive 6, I have negative 6, and they zero out when they come together. So I don't have to do any like puzzle pieces and see how many are missing and do I have any more to put in. All I have to do is crisscross, and I know I'm going to have a neutral compound. And that's why we don't show charges, because this is neutral. I don't want to show any charges. Now, we want to be careful, though, because what I've just said is absolutely true. We always can crisscross and get the right ratio if, okay, I need to finish my statement. If we crisscross and reduce. Okay, so check this out. Here's another puzzle piece, a big BE piece, a big O piece. what would you have written previously for this puzzle piece? You would have written BE1, O1, because there's one piece of each. But if you did crisscross, what would you have written? 2 and 2, okay? So what I need you to see is we're going to reduce if possible. So the statement of what do we do, that step, that final step is crisscross and reduce if possible, okay? Not just crisscross, you don't stop there. Crisscross and reduce. Be very careful about that, and then you can never go wrong. If you correctly crisscross and reduce, the only time students get it wrong is either they don't crisscross correctly, which I don't know what else to say about that, sorry, or they forget to reduce, okay? So crisscross and reduce. It's a two-part final step going on there, all right? So we do write BEO, we would not write BE2O2 because 2 and 2 reduce. And let me just point out, it doesn't have to be 2 and 2 that reduce. It could be 3 and 3, it could be 2 and 4. Now, 2 and 4, what would that reduce to? Well, 2 reduces to 1 and 4 reduces to 2. See what I'm saying? Okay. 3 and 6. The 3 becomes 1 and the 6 becomes 3. And there we go, reduce, okay? So reduce if possible. Like same rules in math class. If you could reduce it in math class, you should reduce it here. Okay. Now, because we're not working with puzzle pieces, but we need those charges to crisscross, so let's review. Most of this should be review. I said a keyword. Most of this should be review. Let's review how to find the charges on the periodic table, because I've not asked you to memorize them. I want you to look them up. Okay. So first off, I want you to annotate this on the notes. I want you to be sure you catch this, because I would say, I don't know why, I say this all the time. All semester long, I will say metals are only positive. Metals can only be positive. Metals are only ever positive. And then still in May, I have students that try to put negative signs with metals. Why? Don't do that, please, okay? So metals can only ever be positive. They will only ever lose electrons. They can only be positive. Thank you. Okay, now I want you to label because you're labeling your notes here, I want you to label the columns, and the first 3 don't surprise you any, because we've done this before, okay? So this is review, +1, +2, +3. Now, let me catch on this before we move on. We usually skip these transition and intertransition metals. We're gonna deal with those next time, okay? So that is actually something we're gonna have to work with. They're special, they're weird, they're unique, okay? We're going to deal with them next time. So we're going to not worry about them. We have +1, +2, +3. Now you probably want to tell me plus minus 4, but no, because metals are only ever positive. So it's only going to be +4. Now look at my periodic table. Notice I'm only showing the metals. What would that mean for these blanks for the non-metals above? Those were the negative 4s. That's why I always said +-4. Those were the -4s, but I'm not showing those. That's what we're only talking about metals in this moment. These metals are +4, and we probably have never talked about that. These metals are +5, and these metals are +6. And tennessine, if it was even around long enough to get a charge, it would be a +7. Again, these new radioactive, I'm not going to bring in radioactive elements for you to work with. That sounds stupid. Okay, so we're not going to worry about them. Okay, I'm not going to use them on any questions. Don't worry about them. But if you like the pattern and want to call it +7, sure, go for it. It would be. Okay, now we're talking about the non-metals. And I want you to annotate this. The non-metals are going to be negative. And I bring this up because students will find out, they'll go online and be looking at something about, Mr. Bellin, chlorine has positive charges too. Yes, it does. But for a chlorine to stick with a metal and be an ionic compound, an ionic bond, and that's what we're doing today, right? We're doing ionic bonding, okay? If the metal is positive, the only way the chlorine can stick is if it's negative. So it has to be negative. The non-metals for ionic bonding have to be negative. There is no other choice. These are just like we've had in the past. So go ahead, write them in as a review, but there's no changes to these. And again, notice I'm only showing the non-metals. What about boron? Boron's really not even going to do a negative thing. Okay, it's not even going to do a positive thing half the time. It does a covalent thing. We're not going to deal with it yet. That's later. Okay. What about the noble gases? Well, if you wanted to put a number there, they'd be 0. They don't bond, they don't gain or lose electrons, so they're 0 charge. So there we go. Okay. So this was review, but we needed to review because you are required to be able to find the charges to know what to crisscross. Am I asking you to memorize them? No, I'm asking you to be able to look up at the table and know what the charge is. Okay. So we're going to do some examples, and these first examples, I actually did step 1 for you already in the example. See, step 1 is you write the symbols. Already did that. So we're going to write the symbols, we're going to write the charges, we're going to crisscross and reduce. Okay. And after we go through writing the formulas, we're going to talk about writing names. Okay. So here's my symbols, K and N. Look them up on the periodic table to find the charges. Hope you see that K is a +1 and N's a -3. And if you need to pause and like find them on the periodic table to know why that is, please do so. Thank you. Okay, so we got a +1, we got a -3 going on there. That was step 2. Step 1, write the symbol. Step 2, find the charges. Step 3, crisscross reduce. There we go. Now I don't normally write ones, and so there we go, K3N. 3 simple steps. That's all there is. Okay, let's try the next one. In fact, I want you to pause and work ahead of me and see if you can like jump ahead. So I'm asking you to pause right now. It'll probably only take you 10 seconds on these next 2 each. Give them a try at least, and then unpause and see how it went for you. So I hope you're back from having paused. Yeah, I'm looking at you. Pause it and work ahead. Okay. So hope you're back from it being being paused. And let's see, B, E, and F. B is a +2 and F is a -1, and we're going to crisscross and reduce. And then there we go. Okay. And then AL and O. And AL is a 3, which is why I do like calling it group 3A, not number 13. I like 3A because that tells you what the charge is, net +3. But +3 and -2 for oxygen. And then we're going to crisscross, so AO2O3. So there we go. It is literally no harder than that. Like, that's it. Those are the 3 steps. Write the formulas. Sorry, write the symbols is what I should say. To write formulas, write the symbols, find the charges, crisscross and reduce. That's all there is to it. Now, I remind you that last statement is crisscross and reduce. Do check for it. None of these 3 in my examples could we reduce, but you should always be checking. That should always be a thought in your head. Crisscross and reduce. Okay, let's talk about naming. Good news, super easy, okay? K is potassium, so we're gonna write potassium. N is nitrogen. Now here's the thing. For a compound, we change the endings to "ide." And again, on my handy dandy chart, which you can download from Canvas, I have a list of here's the elements, the non-metals, because they're the only ones going to be on the end. Here's the non-metals and how to write them with "ide." So we're not going to say nitrogen, we're going to say nitride with a D. Okay, so potassium nitride. And if that sounds familiar, it could be. Okay, like you're going to hear the names of all of our compounds in ingredient lists and everything you do in life. It's going to be everywhere. Soaps, shampoos, soups, ketchups, things like that, all over the place, okay? Like this is something you should be hearing a lot of because it's everywhere. All right, Be is, if you said beryllium, you're right. And be careful, it's not beryllium. There's only one R. Okay. And normally I'm not a stickler for spelling, but you're copying off a periodic table, so copy well, okay? Now, F is fluorine. I'm not going to say fluorine. You're copying off the chart, and you're going to say fluoride. Have you heard of fluoride? Maybe you're using a fluoride toothpaste, meaning it either has, it's usually either sodium fluoride or tin for fluoride. Okay, so that tells us it's actually in a compound. You'll never find pure fluorine in that tube, which would be really scary if you could. Like that'd be really bad, honestly. Okay, it's already in a compound in the tube mixed in with all the rest of the toothpaste. Fluoride. Okay, and then Al is aluminum, and O is no longer going to be oxygen. We're going to call it oxide. So there we go. That's all there is to naming. You write the names in the order listed, and you change the ending to "ide." And it will always be the non-metal you're changing. The metals, the positive always goes first, and the non-metals, the negative, always goes second. So it's always the non-metals. I want to point this out if you haven't seen it already. This little 3 here made no difference to the name. This little 2 here made no difference to the name. This 2 and 3 here made no difference to the name. That's the cool part about naming these. It's just blah, 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 ending in "ide." The numbers don't matter. The numbers do matter to the formula. You're doing those 3 steps: symbols, charges, crisscross, reduce. They matter to the formula, but not to the names. Okay, at this point in time, I want to show you what's going to be asked of you on your assignment. Okay, so your assignment page, which is in Canvas, is going to be formatted in this method. And so just to make it clear, be sure everyone's ready to go for it. If I give you the name, I want a formula. If I give you a formula, I want a name. Okay, so here I have calcium phosphide. So I'm going to do the 3 steps because I want a formula: symbols, charges, crisscross, reduce. 3 steps. Okay, so here's step 1, symbols. Calcium is Ca. Phosphide comes from phosphorus, P. Okay. Step 2, charges. Calcium's a +2, phosphorus is a -3. That's just right there. We reviewed it a few screens ago. And then step 3, crisscross and reduce. Okay, so I'm going to get Ca3P2. Now watch this. I need you to see this. This is what I'm going to show on my paper. I'm going to erase the charges. This should make sense. After crisscrossing, it's now a neutral compound. So I don't want to see any charges because it's a neutral compound. If I were to see a positive or negative, I would think it's not a neutral compound. I don't want to do that. This is a neutral compound. It has zeroed out the charge. Okay, so either work with something erasable, as I warned you at the beginning. You might want an erasable pencil, or I've watched students who will like put the charges over the names and then crisscross, and you can do that. Just be careful. I think that's a lot of where students forget to crisscross and they just write the number straight down instead of actually crisscrossing. Okay, but do not show the charges, please. Okay, let's do potassium bromide. Potassium is K, bromide is Br. So pause and see what you can do, and then unpause, and let's see how it went for you. Hopefully you paused. Okay, so K and Br, and I looked up the charges, and potassium's a 1 and bromine's a 1, and I don't even normally write ones. So when I crisscross and reduce, I really have nothing I need to write when I crisscross and reduce, but I'm still going to erase the charges. I don't want to see charges because, again, this is now a neutral compound, 0 charge overall. Okay, and then antimony sulfide. Again, I gave a periodic table on the back side of the chart. Okay, antimony's way over here, number 51. It's on the, let's see, that'd be the right side of the periodic table. I want to make sure my dyslexia didn't mess me up there. Okay, so right side of the periodic table. Element 51 is antimony, and then we got sulfur for sulfide. So I've got SB and S. And do pause a moment now that you know where they are and see what you can do. Bring it to a completion and then unpause. Okay, I hope you paused. Did you get SB2, S3? 5. Let's go S5. SB2, S5. Okay, so SB is a 5 charge. S is a 2 charge. And then I switched them. So SB2, S5. It's that easy. That's all we have to do. Please don't add any other steps to it because there's nothing else to add to it. That's it. Okay. Hopefully real easy. And in fact, I've had a lot of students say that it makes doing the puzzles easier. And I know if you didn't struggle with the puzzles, that's why this is easy. Struggling with the puzzles makes this easy. If I did this without the puzzles, you'd be like, I'm not sure what's going on yet. Okay. So it does make it easier that we've done that, but these are the 3 steps and you don't need to add anything to it. It takes care of it by those 3 steps. We're going to do formulas to names. And as I said earlier, names are super easy. We go with, hey, what's Ag? Yeah, it's silver. What's P? Phosphorus, which according to our chart is phosphide. There we go. Easy. Okay, so I want you to pause and do the next. Oh, no, too fast. Sorry. Pause and do the next one and the next one and see what you can do. And then unpause and we'll see how you did. So pause now. Pause now. Okay, well, paused or not, I bet by now you even have it written down. Na is sodium, O is oxygen, which I'm going to call oxide. There we go. Okay. And then INI. IN is, maybe you probably have to look that one up. Okay, it's element 49. There you go. So IN is indium. And then I is iodine, which we call iodide. Indium iodide. Now, just by the way, because I like talking about other cool chemistry, history, and stuff like that, indium is named after the fact that when scientists used the spectroscopes and looked at the gas, they saw this indigo colored line that like no other element had. And they're like, oh, no other element has this line. This must be a new element. And they called it indium after the indigo color of that line. Now, I personally would have been like, well, let's call it indigoium. But apparently, no one asked me how to, and it was also way before I was born, but okay. So indium is named after the color of that line spectrum that told scientists, hey, this is a new element we don't know of yet. So there you go, just letting you know. Neat little trivia for you. Okay, so at this time, you have a practice page to do, and your practice page has both a front side and a back side to it. And what I want you to do is just the front side at this time, okay? We're ready for the binary. It says binary up here in the corner. We're ready for the binary practice. So pause the video, or if this is all you need to do, stop the video and work on that. Now I'm about to move on to polyatomic, which is the backside, okay? And so if you need polyatomic, this is actually where you would start the video, all right? Hopefully you've been watching the whole time anyway, if you need both. So there you go. So again, if you need binary, I would recommend you pause now and finish the binary side before you unpause and move on to polyatomic. Because polyatomic ion is actually no harder at all. It's different, but it's no harder. Okay, so I want to talk to you about what a polyatomic ion is. If we could see them, it would look like this. It's a big group of atoms, polyatomic, many atoms, that overall they have a charge. And there's actually one polyatomic ion with a positive, and then all the rest of them have negative charges. Okay, so here is what we're going to do. Nothing different. But polyatomic ions have a special name. That's the only difference. So again, I gave you a list of polyatomic ions and their names, and you get this out of Canvas. Download it, it's ready, it's a PDF for you. Maybe save it to your phone in a safe place so you can constantly look at it over and over again, okay? But you don't need to even use mine. You could just go out there, and I'm sure there's lots of polyatomic ion lists out there. No worries. Okay, so if I give you a formula, I want a name. So what are we going to call Li? Lithium, exactly. What are we going to call C2H3O2? Well, we're going to go to our list, and it's in my list, it's right about here. Okay, C2H3O2 is acetate. Now, notice what we did not do. We did not change the ending. We do not change the ending of things that are on this list. Okay, these names are special. Don't mess with these names. They're already special. We leave them alone. Elements from the periodic table, we would change the ending of, but not anything in the list. That's the only difference. The names don't change. That's what's different. Okay. MgOH2. So Mg is an element, find it on the periodic table, it's magnesium. OH, you'll find it in my chart towards the bottom of the, let me get my directions correct here. Towards the bottom right here, okay, in my chart. Okay, yeah, you could probably just Google what is OH. It'll probably come up as hydroxide. No name change, it already has a special name. Okay, and then we actually have one polyatomic ion that is special in that it is a positive, And so it would actually, it would be in the front because we do the positive part first and then the negative part. So here's my NH4. And I don't need to worry about that too. I'm going to just look up NH4 and I see in my handy dandy list, especially for the positive, that it is ammonium, not ammonia. That's something different. Ammonia is a great window cleaner. I hope you're not really around ammonium that often. Okay. But this is ammonium sulfide. Now, wait. This is a regular element. Notice we did do the name change. So that it might be a little tricky to remember. You're not looking everything up in the list. Some of them come from the periodic table. And if it's the second one and it comes from the periodic table, change the ending tide. That's the only difference. I hope you still found that easy. I mean, yeah, it takes time to look things up, but that's it. I'm not like, there's nothing else I can make that more difficult with. That's it. Okay. Let's try the others here. Now, when I give you a name, I want a formula. So it's the 3 steps: symbols, charges, crisscross, reduce. So let's watch how this happens. Sodium hydroxide, symbols. Sodium is Na, hydroxide is OH from my list. Okay. Charges, sodium's a 1, hydroxide's a 1. So crisscross and erase the charges, because we always just erase the charges. It's neutral. I'm done. 1 and 1 is the same. There we go. 1 of each. NaOH. Sodium hydroxide. Okay, let's try the next one. Magnesium hydroxide. Now check out why I picked magnesium hydroxide to do next. I got magnesium, I got my hydroxide, I get the charges. Now my question to you is, where do you think that charge of 2, where that number 2 gonna go? If you said outside the parentheses, you are correct. So I'm going to tell you now, and students, I don't know, like students felt betrayed or something today, like I never told them this. I'm like, no, this is the first time I've ever told you. It's not like I've been lying to you, okay? You never mess with what's in the parentheses. You cannot mess with what's in the parentheses. That always stays the same. So when you're ready to crisscross, it will always, 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 always be outside the parentheses that those crisscross numbers go to. Okay, so there you go. Now you know. It's not like it was withholding it. You just never needed to know until now. So now you do. You're welcome. All right, so let's keep going. Ammonium is NH4. Got my parentheses going on. I don't care about charges yet. Got my fluoride is fluorine. Okay, that's just an element. Now I look up the charges. Ammonia is 1. And fluorine is 1. And when I crisscross 1, it's not a whole lot of anything happens, right? Okay. Now I want to challenge you. Pause the video. Try to work the next 2 and then unpause the video and come back and see how you did. It really will. It's the struggle that makes you stronger. So it really will. Just giving yourself this 30 seconds to try it on your own is going to make a huge difference in how much better you're going to understand this. So give it a try and see how well you do. And then unpause when you're ready. Okay. Hopefully you paused. I've got NH420. Now, let's talk about this real fast. The NH4 in the parentheses doesn't change, but it had a 1. And the O, the oxygen from oxide, it was a -2, and then I swapped. So NH420O1. And I don't write the 1. And you can write the 1, but it's going to just honestly be a waste of time to write the 1. So there we go. Okay, and what'd you get for the next one? Ammonium and phosphate are both on the list. So what do we do when they're both on the list? Nothing different, actually. Hope you figured that out. Now notice I still crisscrossed. Ammonia is a 1, but phosphate is a 3. Don't confuse it with phosphite. This was phosphate, okay? 1 and 3, and I crisscrossed. So now it's 3 and 1, and I don't write the 1s. So that's how it looks. So I hope you see polyatomic ions actually change very little. It just means you're going to be consulting this list. That's all that means, okay? Is that going to make it any harder? I would honestly say no. That's not going to make it harder. Is that going to take a little longer because now you're looking these up in the list? Yeah, a little bit longer, but you should still fly through these really fast if you get it. Look, if you're sitting for like 3 minutes on the same problem you need a little more explanation, a little more clarity, come see me, okay? Because like surprisingly to you, not to me, surprisingly to you, like usually students get hung up on like one simple little question. And as soon as I get it answered, they're like, oh, that makes sense. And they're ready to go, okay? So don't sit there for hours on the same problem, not knowing what to do. Come ask. All right, that's all the notes. You should now do the back side of the practice, the polyatomic ion part, okay? And then front and back, those should be done by the end of class time today is what I said. So those should be done as soon as possible, as soon as you get back. So there you go. Okay, good luck. Again, if you need some more clarity, a little more help, if you find you're taking more than say 2 minutes on each problem, you want to come chat with me for like 5 minutes, maybe less. That's all it would take. Let's just talk and see how it went for you and see what things you're still trying to get put together in your head. The struggle is where you get stronger, but don't struggle without getting help because then you're going to be inefficient. Okay. So like 5 minutes and move on and try the next one because something is not sitting well with you and I can fix that for you. Good luck on the assignment. I will see you next time.